So this will be the last part of section 2.4, I guess part 3. It's going to be very short. I just didn't want to shove this section at the end of part 2, thinking that a lot of students might just kind of ignore it, and this is on the test. So for each of the questions between 61 and 68, there's a part A. And essentially, part A wants me to find any value of x where the tangent line is horizontal. And that basically tells me to find the derivative set the derivative equal to 0, and solve for x. What this is going to give me, it's going to give me the x value of a point where the tangent line to the graph is horizontal as opposed to some other slant. There's something that we may or may not remember, but from college algebra, but if I had e to any power and I set it equal to 0, this will have no solution. It's the only algebra that comes up in these problems that you might have not remembered from Math 151. So the result of part A is going to actually give me an x coordinate of a point. When I'm solving for x, that's kind of implying an x value of a point. And when I move on to part B, it wants me to find an equation of a tangent line for the value, any values of x found in part A. And in order to do part B, to find an equation of a tangent line, I need a point and a slope. So what I'm going to do is I'm going to do part A, and the answer to part A is going to be the x coordinate of my point. Because I'm finding a horizontal line, the slope of my line is going to be 0. And just like we did at the end of section 2.3, when I get down to part B, when I go to find the equation of a tangent line, I'm going to have to do one more step to be able to have the full point. And to find an equation for a line, you need an x and a y coordinate of a point, and you need a slope. Because the tangent line is horizontal, the slope is 0. The value of x that I get in step A is the x coordinate of the point. And when I get down to part B, I'm going to find the y coordinate by plugging or putting the answer for part A into the original function. And that will give me a y coordinate, and after I have the x that I get from part A, the y that I get from plugging the x into the original function, and the slope of 0 because the tangent line is horizontal, when I go to do part B, I'm just going to use the y minus y1 equals m times x minus x1 equation. I'm going to plug the x and y into the x1 and y1 from my point. I'm going to plug 0 in for the m, and I'm just going to take that and solve for the solve for y. So if I'm doing problem 62, I told myself I need to find the derivative, and this is an exponential function, and the derivative of any exponential function, it's going to be the coefficient times the natural log of the base times the derivative of the exponent times the original exponential piece, everything but the coefficient. And for this particular problem in 62a, there's not a number written to the left of the e, so the implied coefficient is 1. The base is e, and eventually I need to do the natural log of the base, and the natural log of e, it's already on my calculator, the natural log of e, where I just type the ln button, then second and divide, the natural log of e is 1. So the coefficient is 1, the natural log of base is the natural log of e, because e is the base, that's equal to 1. The derivative of the exponent is 5x squared, and the derivative of 5x squared, I just go 2 times 5 is 10. Lower the exponent by 1 and get a 10x. And then the original exponent part is the whole function. It's everything but the coefficient, if there was a coefficient. So when I go to write the derivative down for part A, I'm going to go y prime equals to coefficient 1. I shouldn't write things that are equal to 1. Times natural log of the base equal to 1, shouldn't have written either of those, times the derivative of the exponent, 10x, times e to the 5x squared, the original exponent part. And so usually when we do a derivative of an e that doesn't have a coefficient, we only do these two parts. And for the next few derivatives, when I do my derivatives of e's, I'm going to skip, if it doesn't have a coefficient, the coefficient part, and I'm going to skip the natural log of the base, because when the base is e, the natural log of the base is equal to 1. So this is finding the derivative part of part A. Now I'm going to set the derivative equal to 0. My derivative comes up nice and factored. I'm going to set the derivative equal to 0 and solve for x, equal to 0 and solve for x. Because the derivative is factored, I can find the values of x where the derivative equals to 0 by simply splitting the two factors and setting each equal to 0. The first factor of 10x, to solve for x I need to divide by 10, and I get x equal to 0 because on the left hand side there's a fraction with 0 in the numerator and fractions with 0 in the numerator equal to 0. And the right hand part is an e to a power, and an e to a power doesn't give any solution. So my answer to 62a is x equal to 0. So I did exactly what I said I needed to do. I found the derivative, I set the derivative equal to 0, I solved for x. Because the derivative was factored, I split each of the factors up, set them equal to 0, used the fact that e to any power doesn't have a solution when you set it equal to 0. Now I'll move on to part B. So for part B, to find an equation of a line, I need a point. The answer that I got from part A is the x-coordinate of the point. I need a slope, and the fact that the tangent line is horizontal tells me the slope is 0. Now I'm going to get the y-coordinate of the point by plugging the answer 0 into the original function for x. So I'm going to get the y. I'm going to go y equals e to the 5 times 0 squared. And if I don't know that that's equal to 1, because the exponent simplifies to 0, on my calculator I could go second and ln to get e with an exponent, and then 5 times 0 x squared, and that's going to give me 1, because this is really y equals e to the 5 times 0 power, because 0 squared is 0 and you do exponents first. That gives me e to the 0 power, and anything to the 0 power is 1. So that's the y coordinate of my point. So now I have a full-fledged point, both an x and a y coordinate. And I'm just going to use the y minus y1 formula equals m times x minus x1. On the left-hand side for the y1, I'm going to plug in 1. On the right-hand side for the slope, I'm going to plug in 0. And then for the x1, I'm going to plug in 0. The right-hand side's going to just turn into 0 because 0 times any quantity is 0, and 0 times that parentheses gives me 0. And I'm just going to add 1 to both sides. There are definitely shortcuts to get the equation of the line when the slope is 0. Basically, you can just write the equation y equal to the y coordinate of the point. So that's all of 62. So give 61 a go and see what happens. And I'll move on, and I'll do 63 with you, and I won't do 64. So for 63 part A, if you want to pause the video and give this a try, that would be wonderful. First thing I'm supposed to do is find the derivative. Because there's multiplication and both factors have an x, I need to use the product rule. So I need to know the first factor, which is the x, the second factor, which is e to the x. I need the derivative of the first. It's an x to the first power term. The derivative is just the number in front of the x, and the number implied in front of the x is 1. And the derivative of the second, it's an e. And instead of doing all 4 pieces, the coefficient of 1, the natural log of the base, which is natural log of e, which is equal to 1, times the derivative of the exponent, times the exponent, the e part. So for this derivative, I'm going to skip the coefficient because it's equal to 1. I'm going to skip the natural log of the base because the base is e and the natural log of e is equal to 1. For the derivative, I'm just going to write the derivative of the exponent times the exponent part. So I'm going to do the derivative of that exponent, which is x. The derivative of x is just the number in front of the x, which is 1. Times the exponent part. So the derivative of the exponent is 1. The exponent part is e to the x. So the derivative of the second is just e to the x. Now I'm going to do the product rule by multiplying each of these and adding them. So for my derivative using the product rule, it's first factor times derivative of the second, which is x e to the x, plus second factor times derivative of the first, e to the x times 1. I'm going to factor out a common factor of e to the x, because on either side of the plus sign there's an e to the x. After the common factor of e to the x, I'll write a parentheses, and to the left of the plus sign there's an x, to the right of the plus sign there's a 1. When you take the e to the x's away, you're left with an x on the left side of the plus sign and a 1 after the plus sign. So that's finding the derivative. Now I'm going to set the derivative equal to 0. And because it's factored, when I set it equal to 0, I can just take each of the factors and set it equal to 0. The first factor is an e to a power, and e to a power equal to 0 doesn't have a solution. The second part, you minus 1 from both sides and get x equal to negative 1. So for 63 part A, the answer is just x equal to negative 1. So done. I found the derivative. I set the derivative equal to 0. I solved for x. Now I'm going to move on to part B to find the equation of the tangent line. I need to create a point and a slope. The x coordinate, the answer that I got for part A is the x coordinate of the point. The slope is 0 because I'm finding an equation of a horizontal line. I need to plug the y coordinate into the original function, the x e to the x, to get the y coordinate of the point. And then I could use the y minus y1 equals m times x minus x1. So for 63 3, part B, the original function before I took its derivative was x e to the x. I need a point. The x-coordinate of the point is -1. That's the answer that I got for part A. The slope is 0 because when you plug in, when the line is horizontal, the slope is 0. And for my y-coordinate, I'm just going to take the -1 and plug it in for each of those x's. So I'm going to go -1 e to the -1 power. I'm going to make this have a positive exponent by moving the e down to the denominator of a fraction. And I'm not going to write what this is equal to in terms of a decimal, because if I did -1 second ln -1 power, I get an ugly decimal, and I'd rather my y-coordinate have an e than be a decimal. So for 63b, I have the -1 over e for my y-coordinate. Now I'm just going to go y minus y1 equals m times x minus x1. And for y1, I'm going to put -1 over e, so I'm going to get y minus -1 over e. That double negative is going to turn positive, equals m, which is 0, times x minus x1, which is x minus -1. That double negative would turn positive, but it hardly matters, because on the right-hand side, I'm multiplying 0 by a parentheses, and that whole thing will simplify to 0. The left-hand side, I'm going to make the double negative positive, and then I'm going to minus 1 over e from both sides. I'm going to get my answer to 63b. On the left-hand side, I made everything cancel but the y, and on the right-hand side, that simplifies to -1 over e. So 2 more. You can try 65. I'm going to do 66. So for 66, part A, I need to find the derivative. There's multiplication. Both factors have an x. I need to use the product rule. My first factor is x plus 2. My second factor is e to the x. The derivative of the first factor, the derivative of that 2 is 0, the derivative of that x is 1. And now I'm going to shortcut my derivative of an e. If I'm finding the derivative of an e that doesn't have a coefficient, the derivative is just the original exponential function, and to the left of it, the derivative of the exponent. The exponent is just x, and the derivative of a single x is just 1. So the derivative of the second is just e to the x. I didn't need to write the coefficient times the natural log of the base, because each of those is equal to 1. Now I'm going to go multiply, multiply. So my derivative for 66a, y prime equals the first factor, x plus 2, times the derivative of the second, e to the x. Probably should have written that first, but it's not going to matter. Plus the second factor, e to the x, times the derivative of the first, which is 1. Pull out my common factor of e to the x. Technically, what I'd have left is x plus 2 to the left of the plus sign and 1 after the plus sign. The parentheses that I had around that x plus 2 isn't necessary when you pull the common factor away from it, because you've gotten rid of the multiplication. So inside the parentheses after the common factor is x plus 2 plus 1, which comes out to x plus 3. I'm going to set the derivative equal to 0. So I found the derivative. Now I'm going to set the derivative equal to 0. I'm going to go e to the x times x plus 3 equal to 0. I'm going to set e to the x equal to 0, x plus 3 equal to 0. E to the x equal to 0 has no solution. X plus 3 equal to 0 has a solution of x equal to -3. So the answer to 66a is this x equal to -3. Done with part A, now move on to part B. For part B of 66, Need that original function, y equals x plus 2 times e to the x. I need a point. The x coordinate of the point's the answer that I just got, -3. I need a slope, and because I'm finding horizontal lines, the slope is 0. I need to get the y coordinate of the point by plugging the answer that I got for part A into the original function for x, and that gives me -3 plus 2 e to the -3. The -3 plus 2 simplifies to be a -1. I could drop the parentheses when I combine the two terms in the parentheses to 1, and I can make a positive exponent by creating a fraction and putting that e to the -3 in the denominator. So now I'm going to just go y minus the y coordinate of the point, which is y minus -1 over e cubed, equals 0 times, which is the slope, x minus the x coordinate of the point. The right-hand side comes out to 0 because 0 times any quantity is 0. The left-hand side, the double negative goes positive. And then I'm going to subtract 1 over e cubed from both sides. And get y equals -1 over e cubed. When you're finding an equation of a horizontal line, really it's always going to be just y equal the y coordinate of the point. So you could actually skip all this and go directly to the answer, because anytime you're finding the equation of a horizontal line, the answer is just going to be, the equation is going to be y equal the y coordinate of the given point. So give 65 a go. We just have 67 and 68. I'll do 68, leave you 67. So for 68, I need to find the derivative for part A. There's multiplication. Both factors have an x. The first factor is x. The second factor is e to the 3x. The derivative of the first factor, it's a first power term. The derivative is just the number in front of the x, which is 1. The derivative of the second factor, it's an e without a coefficient. So I don't need to do, the coefficient times the natural log of the base times the derivative of the exponent times the exponent piece part. So the coefficient is 1. The base is e, and the natural log of e is 1. So when I do the derivative of an e that doesn't have a coefficient, I just take the derivative of the exponent times the exponential function itself. The exponent is 3x. It's a first power term. The derivative of a first power term is just the number in front of the x. So 3x has the derivative of 3. And then the exponent part is e to the 3x. So that's fast derivatives. Usually when I do derivatives of e's, I do them fast. And now I'm going to do multiply. So the derivative for part A, first factor x times the derivative of the second. So I'm going to write it backwards. I'm going to flip-flop these. I'm going to do first factor times derivative of the second written backwards, plus second factor times derivative of the first. And I forgot a 3x here. So derivative of the second times the first, or first times the derivative of the second, whichever order seems easier, and then second factor times derivative of the first. Pull out the common factor of e to the 3x that are on either side of the plus sign. When I take that common factor away, I'm left with a 3x to the left of the plus sign. I'm left with a 1 after the plus sign. I'm going to set that equal to 0. It's factored, so I can just set each of the factors equal to 0. E to any power doesn't have a solution. For the 3x plus 1 equal to 0, I need to subtract 1 and divide by 3. And I get x equal to -1/3. So for 68a, my answer is x equal to -1/3. That's the x coordinate of the point that I need to work with. I imagine for 67, it's going to be x equal to negative 1/2. When I move on to part B, the original function is y equals x e to the 3x. The slope, because I'm finding an equation of a horizontal line, is 0. The point, its x coordinate is negative 1/3, and I need to find its y coordinate. So I'm going to go y equals negative 1/3 e to the 3 times negative 1/3 by taking each one of the x's in the original function and changing it to negative 1/3. And the exponent, those are reciprocals, but they're opposite signs, so those are going to multiply out to be negative 1. So this is going to give me negative 1/3 e to the negative 1, because reciprocals, 3 times 1/3 would be 1, but positive times a negative gives me a negative. And now I'm going to create a fraction, or move that e to the negative 1 down to the denominator to make its exponent positive. And the y coordinate of my point is going to be negative 1 over 3 e to the first. I don't need to write the exponent of 1. Now I have everything I need. Lazy, if I want to, and it's probably preferred, because the slope is 0, I know the answer is just going to be y equals the y coordinate of the point. But if I wanted to go through the work, I'd go y minus the y coordinate of the point equals m times x minus the x coordinate of the point. On the right hand side, 0 times anything gives me 0. On the left hand side, the double negative is going to turn positive. And then I'm going to minus 1 over 3e from both sides. On the left hand side, I'll get a y. On the right hand side, I'll get that minus 1 over 3e. I think my video is getting ready to hiccup, so this is where I'm going to stop the video and have you do 67, and we'll be done with this section.